Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 7.3 entitled Solving Linear Systems by Elimination. And today we're going to look at the third and final method for solving systems of linear equations, and it's known as elimination. And I think this is the easiest, most straightforward, you can use it every single time type of method. It's faster than graphing. It's a little bit better than substitution because you're not putting an equation into another equation, but there is still some work that you have to do up front. Like you might have to rearrange the equations so that all the variables are lined up, and the best way to do that is to write the equation in standard form. So you have all of your x's plus all of your y's equals all of your numbers. And then you might have to multiply by a number. The thing we want to look for in elimination is that you have the same variable with the same number, but with opposite signs. So you want like a 5x and a negative 5x. And if you don't have that, you might have to multiply one or both of the equations by something to get that to happen. Now, once that happens, then you just add up the columns, you add the equations together, and then you solve for the variable. Now, once you get that variable, then you'll have an answer like x equals 4, and then you just substitute that into either one of the other equations so that you can solve for y. Okay? And then you want to check your solution as well. Make sure it's really a solution to the equation or to the system. So if we take a look at example 1 here, now we only have example 1, but it's got 4 parts. It's got A, B, C, and D. So for example 1, part A, you notice that it's got 2 equations. They're in standard form. You have your x's, then your y's, and then your numbers. So the columns are all lined up. Then you want to look at the x's and the y's and say, okay, do I have the same amount but with opposite signs? So if I look at my x's, I have 1x and 1x. So I have the same amount, but they're not opposite signs. So I'm going to look at the y's. I have 1y and a negative 1y. Okay, so now I have the same amount with opposite signs. So I'm going to add up these equations and the y's will eliminate. So this first problem is pretty straightforward. We don't have to rearrange anything. We don't have to multiply by anything. We can just add them up. So I have 1x plus 1x is 2x. 1y minus 1y is nothing. Y's are gone. And then 4 minus 10, that's negative 6. So now I have 2x equals negative 6. So when I divide by 2, x is going to be negative 3. Look at that. I did 2 steps and I have half of my solution already. Now, to find out what y is, let me erase this little mark here where I eliminated the y's. I'm going to take this value for x and I'm going to substitute it back into either one of these equations, whichever one you think is easier. I'm going to put it into the top one. So I'll have x plus y equals 4, and x was negative 3 plus y equals 4. So when I add the 3 over to the other side, y will equal 7. So now my answer is negative 3, 7. Okay, and if I check that, negative 3 plus 7 is definitely 4. And then negative 3 minus 7 more is negative 10. Very good. So both equations give me a true statement when I substitute my ordered pair in. Okay, so let's try that again in part B. Now everything's written correctly here. I have my x's and then my y's and then my numbers, so I don't have to rewrite anything. So now I'm going to look at my x's and my y's and see if I have the same number but with opposite signs. Now the x's, I have a 2 and a 1. Oof, not same number, not opposite signs. So let's look at the y's. I have a 6y and a 6y. Oh, same number, but with opposite signs. So how do I get one of these to be negative? Well, I would just have to multiply either the top equation or the bottom equation by a -1. Okay, doesn't matter which one we multiply. I'm just going to pick. And I'm going to multiply this whole bottom equation by a -1. That'll change my sign here, so that way one is a 6 and one is a -6, and then when I add them up, they'll eliminate. So my top equation, I didn't do anything to it, so I'm just going to rewrite it. And then the bottom equation, I'm going to multiply every single thing by a -1. So I'll have -1x minus 6y and -3. And now I'll add them up. So 2x minus 1x, that's an x. 6x or 6y and -6y, they eliminate. And 6 minus 3 is 3. There we go. X equals 3. Now I still have to solve for y. So again, I can substitute into either equation, either the top one or the bottom one. But the bottom one looks a little easier just because it doesn't have a number in front of the x. So if I have x plus 6y equals 3, when I substitute, I'll have 3 plus 6y equals 3. And then I can solve for y. So I have to get my 3's all on the same side there. So 6y equals 0. And if I divide 0 by anything, I just get 0. So my solution is going to be 3, 0. Now, remember, just because you got 0 for an answer doesn't mean you did something wrong. 0 is still a number. And we could check the solution. 2 times 3 is 6. 6 times 0 is 0. 6 plus 0 is 6. And 3 plus 6 times 0 is 0. So 3 plus 0 is 3. There you go. So this is my solution for that system of equations. Okay, so let's step it up a notch now for part B, or I'm sorry, C and D. For part C here, I have everything lined up. I've got my A's, and this time I have Z's, and then numbers. Doesn't matter what the variables are, as long as all of them are in one column together, and then all of the other kind are in another column together. So now I'm going to look at my numbers. I have a 2 and a 3. Oof, not the same, and not opposite signs. And then I have a 6z and a -7z. Oh, okay. So one is positive and one is negative. That's good, but they're not the same sign. Okay, so if I wanted to get the same number in front of the A's, let's see, 2 and 3 both go into 6. So I'd have to multiply the top by 3 and the bottom by 2. That way I'd have a 6 and a 6. If I wanted to eliminate the Z's, I'd have to multiply the top by 7 and the bottom by 6. Then I'd be dealing with 42's. So I could either work with 6's or I could work with 42's. Now it doesn't matter which method you take or which path you take here. Both of them will get you to the correct answer. Okay, but I'm going to multiply everything in the top equation by 3. That'll give me a 6a. And then I'm going to multiply everything in the bottom equation by a -2. That way I get a -6a. And that way I'm working with smaller numbers. Okay, so 3 times 2 will be 6a. And 3 times 6 would be 18z equals 12. And then in my bottom equation, I'll have -6a. -7 times 2, or -2 is positive 14z. And then a -12. Ooh, okay. Now, I have a 6a and a -6a, so they eliminate. 18 and 14 is 32. And here I get 0. And remember, when I divide 0 by anything, I get 0. Okay, so now I can take that and substitute it into either equation. I'll just pick the top one. Okay, so I'll have 2 times a plus 6 times 0 equals 4. Well, 6 times 0 is just 0. So that's 2a equals 4. So if I divide by 2, a is 2. There we go. So my solution, now alphabetically, remember I have to put my answer in alphabetical order. 2, 0 is going to be my solution. Okay, now for part D. Now this one is probably the most complicated that we've seen because it's not in a nice order. I've got my x's, and then a number, and then a y, and then I've got x, and then a number, and then a y, but the equal signs are kind of out of place, okay? So I need to get my x's and my y's together, and then my number on the other side. So I'm going to subtract the 3y over to the left, and then subtract the 1 over to the right. Okay, so I'll have x minus 3y equals -1. So I'm just putting it in standard form. Okay. Now for the bottom equation, I'd have to move the 3y over to the left, so I have to add the 3y over. So I'll have 2x plus 3y equals 7. I don't have to do anything with the 7 because he was already on the right side. Okay, so now I have a system that's all nice and in standard order. So now I have my x's lined up and my y's lined up and then my numbers. Now hopefully you've noticed that the y's are what we're going to eliminate because they have the same number in front of them but with opposite signs. So I have a 3y and a -3y. So even though this one had some rearranging that we had to do, I don't have to do any multiplication now. So that's good. But sometimes you can do both. Sometimes you can rearrange everything so it's in standard form and then still have to do what we did in part C, where you have to multiply equations by something. So here I have a 1x. So when I add, I get a 3x, and then the y's eliminate, equals 6. So when I divide, x equals 2. And then again, to solve for y, I'm going to substitute that into either equation. Okay, I'll put it in the top one. So I have 2 plus 1 equals 3y. So that's 3 equals 3y. So 1 equals y. So my answer here will be 2, 1. And again, remember, you can check these. You can substitute that ordered pair, 2, 1. Substitute it into both equations and make sure you get a true statement for both. Okay, so I like the elimination method because it's very orderly, very systematic. It's very step by step. Okay, so just make sure that you have your columns lined up with your variables so that the equations are in standard form. Look for variables that have the same number but with opposite signs. And if you don't have that, you have to multiply by something to get that. And then you just add, and then you do your little substitution step at the end. And again, this is a process where you definitely want to practice it over and over and over so you get really, really good at it. Now, on your quiz and your test, you'll be given problems where you are told to do a certain method. So you have to do the graphing method, or the substitution method, or the elimination method, just so we can see that you know how to do the method. But ideally, you could do elimination for every single problem if you wanted to. Okay? So definitely practice this. And if you have any questions, come on in and see me before school.